Hi to all the students. How are you all doing? Let's be in the chat. Yeah, I'm looking at the chat right now. I can clearly see we have Khushi, we have the genius Yuva, and who else is there? Vidya is there. Amazing. Good. So we will be diving into this class where we will be starting up chemical bonding. Stay tuned. Let's talk about this. So for those who haven't followed me yet on my Telegram channel, do join it, and on Unacademy also you can join me. You can actually follow me over there so that you can actually see which all classes are going to be there, which all plus courses are going to be there, which all special classes are going to happen. And do follow the Telegram channel of this YT channel as well, your YT channel as well, which is JEE English Unacademy. And apart from this, guys, do remember that ultimately I have an JEE mains and advanced crash course for 2021 students, and there are a lot of courses which are there on Unacademy Plus for 2022 students as well. And if you are looking for some batches where everybody is teaching all the subjects in English, then we have Spark batch for 2023 students and Shine batch for 2022 students. This is the ultimate opportunity to grab these particular, get into these particular courses, because ultimately the frequency of English batches are slightly less, and I do not want any student who wants to learn in English should miss out these amazing batches. And for this you have to enroll on Unacademy's platform Plus and Iconic. And for 2022 and 23 students, every week there are new batches coming up. So 1st, 8th, 15th September, there are so many. This is for the half of the month. In the next half of the month there would be more batches. So always whenever a student comes to Unacademy Plus or Iconic, he and she never gets chance to see recorded classes. And over here, guys, pay attention. For 2022 students, we have the U set, and first 1000 rankers will get up to 100% scholarship, and this is going to be on JEE pattern. The dates for this test is 11th and 12th of September. So it's coming very soon. You can scan this particular QR code and use the code LUVGURU to get your max this enrollment free. And whenever you guys are going to get into Plus as well, with this code you'll get the maximum discounts. And for the Combat as well, Combat is again a scholarship test for everybody. And over here you should remember, this happens every week. USET never happens, okay, I mean on a weekly basis, but Combat happens every week, Sunday 11 AM. Again, use the same code. Rank 1, 2 and 3 holders will get 1 year of JEE subscription free. 75%, 50% and 25% scholarship is also available. Have you guys marked the attendance? Because I cannot see that. How many of you have marked the attendance? Let me know. And guys, do remember that I am going to recommend you few of the courses, few of the subscriptions over here. Droppers and 2022 batch students should go for 12 months and 23 students should go for 24 months. And what you guys will really get whenever you guys are over here, so the first and the foremost thing that you should look for is the best educators, right? Because you might be available in any part of this particular sweet nation, and then you may or may not be having the good exposure with a lot of teachers. And this is where Unacademy has best educators for you. You should just come into their live classes. You can have their live interactive classes where you can actually ask your doubts. Structured courses are there. Notes and PDFs are going to be available from teachers. Live test and quizzes happens on the platform. So even in the classes, live test and quizzes happens. And you should remember, in the case of Iconic, study planner, study material, expert guidelines, test analysis, there are a lot more features when we compare from Plus. But yes, what is the best thing about Unacademy? The first and the foremost thing, India's best educators, and apart from that, the best price. Because we do not compromise with the quality education, and quality for that particular quality we are charging you the least, where we are asking for only just 34,650 rupees for 12 months of subscription. Just divided by 12 and you will get the how much does it cost for 1 month. And when we talk about 24 months, then ultimately it's just 50,400 rupees. And now over here we are moving on to the next, this particular chapter where we are starting up chemical bonding. Do we have material around us? Do we have substances around us? Do we have solid, liquid, gases around us? Right? We have a lot of matter around us. Is all the matter that is around us is available in elemental form, or do these elements also react? Obviously these elements react, right? There are a lot of elements which are available in elemental form as well. Can you name very few? I'm going to just ask for very few examples of the substances available in elemental form around us. Let's see, because anyhow I'm the one who is actually going to take a lot of examples from you guys, then only I start the class, correct? Let's see. This is where we are always starting up a class with a brainstorming, a small amount of brainstorming session, and then we will get into the concepts. But I should really know. Sodium. Chris is saying he has sodium around him. Okay. Aluminium. Okay. Aluminium foils. It's elemental, correct? Right? Aluminium. What else? Gold. Correct. Silver. Absolutely. Let's see. Anyhow, gold is not pure. And the gold that we wear, the silver that we wear is not pure. But okay, amazing. I'll take it. We'll take that particular. Okay, bromine. Where do you have bromine in the elemental form? I'm not talking about the name of the elements. Come on, boys and girls. I'm not talking about the name of the elements. What I'm talking about is those, these elements should be available around you in the elemental form. Yes, the substances should be there in the elemental form. In the air, do we have N2? In the air, do we have N2? Is this the elemental form of nitrogen? What about O2? Is this the elemental form of oxygen? Let's start with air. Let's start with what we are actually consuming even right now. Too much of nitrogen went inside, too much of oxygen went inside. Correct? Now you got it? Even aluminium is a good answer. Even platinum, gold, silver, whatever we are wearing. Let's not talk about the impurities. Yes, correct answer. Even, do we have iron? Do we have, pure iron around us? Let's not talk about slight impurities, but yes, we do have it. If you go to a local shop, if or maybe a blacksmith, and you look for a hammer, what's the top part? It's the iron. They make it with the iron. Yes. So yeah, good. But I was actually expecting somebody to tell me N2 and O2 as well. But never mind. We'll talk about a lot of stuff. And today's class is going to be very much important. Why? Because today in this particular class, I am going to teach you the Lewis dot structure and the Lewis formula for molecules as well. If a student does not know how to make a Lewis dot structure for the atoms and the molecules, you will always have a problem remembering the structures. You will always have a problem with making up structures for any compound. The oxo acids of sulfur, phosphorus, nitrogen, whatever. You will always have. If you miss this particular session, is what my suggestion is. So do not miss it, okay? And now let's move ahead. So whenever we talk about the chemical bonding, so the attractive forces, the attractive forces between atoms, ions, etc. Right? So what's between oxygen and oxygen? They form double bond. Why one oxygen is sitting with another oxygen? Obviously there is a type of interaction. They are loving each other. They are liking each other. That's the reason they're sitting over there. Together in the chemical species is called chemical bond. We'll talk about which all type of chemical bonds are there. Right? If you actually hold a hand of your friend, right? If it is a kind of some stupid race where you actually have to hold the hand of your friend and then you do have to run. Okay. Why did I say stupid? Because it doesn't happen in Olympics, right? It doesn't happen everywhere. But yeah, but school, makes such kind of races. So what is this? When you're holding up the hand of your friend, or when we handshake, what's that? it's a type of bond actually. It's a type of interaction between you and the other person, right? Similarly, whenever we are going to talk about the chemical bonds, it's the handshake. It could be permanent handshake, है ना? It's a kind of handshake between two atoms. But yeah, they can actually keep this handshake for longer. They can actually keep this handshake for longer. Okay? Sir, actually what is chemical bond? Please say. Okay, I mean we're talking about chemical bond itself. Okay? It's an interaction. So there are going to be protons, there are going to be electrons, we are going to talk about it, don't worry. The whole chapter is about chemical bonding. We can't just end the chemical bonding as a chapter within a few seconds. Okay, so we'll do it. So first and the foremost thing that we are talking about is, why do elements forms bond? Why do they actually stay together? Why not? Why, if we talk about sodium, which is in elemental form, and chlorine, which is an atom over here, why do they keep come together? Why can't chlorine stay as chlorine, and why can't sodium can stay sodium forever? The answer is the stability. The first and the only reason they are all doing is because of the stability. Who in this world, or what in this world, is not doing anything for stability? Everybody in this world is actually running for stability. We work for stability in life, and we work for better and better stability in every scenario, right? Even if we are actually looking for aliens in the space, we want to be sure whether somebody is there or not, so that we can feel much more secure and stable. So just giving you some examples, correct? Everything which is happening around us is happening for stability. Do you agree? Or are we doing anything to destabilize anything? No. Even no matter how much pollution we have given to this particular earth as a planet, and to our planet, and we have done a lot of bad things. I mean, polluting or destroying forests, but we still now want nothing to get destabilized. That's the reason we talk about plant more trees, right? We talk about a lot of stuff. We talk about using electric cars. So we do not want anything to get destabilized, correct? So now this is what we're talking about. We are going for stability. These elements are also going for stability. And in the previous class, in periodic table, I told you about the electronic configuration, right? The noble gases, when we talk about helium, the electronic configuration is 1s2. When we talk about neon, it comes out to be 1s2, 2s2, 2p6, and then later on argon, krypton, xenon, radon. Every gas is having an electronic configuration of np2, np6. This provides stability. This electronic configuration provides stability. How many electrons are we talking about? ns2, np6. So total we're talking about 8 electrons in their valence shell, not anywhere. We're not talking about 8 electrons, we're not talking about just oxygen. Okay, we're talking about 8 electrons in valence shell. Awesome. Now guys, pay attention. Over here, when we talk about sodium, what is the electronic configuration of sodium, boys and girls? We'll write it. What about chlorine? We'll write both of these, okay? So we have 1s2, 2s2, 2p6, 3s1. Wait, oh, see? What have I written? 1s, 3s1. Sometimes a subconscious mind can do something opposite as well, right? That's the reason people are afraid of AI. You know that? How many of you know that, there are people and they have their own theory that AI for human, for the mankind, for the, this race is going to be dangerous. Let's talk about, the chlorine. What is going to be the electronic configuration of chlorine? Pay attention. 1s2, 2s2, 2p6. Till here it's neon. 3s2, 3p6. Which one are we talking about till here? See, ultimately we're talking about argon, and chlorine has 1 electron less than argon. How many electrons does chlorine require? How many electrons does chlorine require to become a noble gas? To be like a noble gas, not become a noble gas, but to be like a noble gas. to have the electronic configuration like a noble gas. It just requires one electron, है ना? So it requires one electron, but how many electrons does sodium wants to gain or lose to be like a noble gas? Not to be like, but yeah, the electronic configuration should be like a noble gas. So what if this one electron can be provided to the chlorine? See, you want to buy food, somebody is selling food. What will you do? You'll go, you'll tell them, they'll be like, give us money, I make food for money. Amazing. Deal, right? Even when we talk about chemical bonds, it's a deal. Vidya was asking me, what is a chemical bond? It's actually a deal of electrons. Whether they are going to completely share it, completely give it to somebody, or are they going to keep it mutually between each other? That's what it is. Okay? So ultimately, what exactly happens? Sodium says, I want somebody who can take this electron from me so that I can become sodium plus, which is going to have a neon gas configuration. And when we talk about chlorine, he just wants one electron to be gained so that it can have argon-like configuration. And they both are stable. And after that, they don't really care what happened exactly. Okay? Is this clear? Both of these things. Why is the electron exchange happening over here? This is a complete exchange. So over here, as we are actually forming up a cation and as we are forming up an anion, this is called the ionic bond. Sodium and chlorine are going to be very much close, but that electron would be getting exchanged. That outermost electron will get in the other shell. Okay? So this is sodium only. Don't worry. Is this clear? Yes or no? This is sodium plus. The outer shell is getting removed because there's no point of simply having extra electron and the extra shell. But whereas if you would see this shell, it is completely filled, right? Awesome. Now let's talk about the next one. What I can see over here is we see the atomic numbers. So how did you find electronic configuration? We have to look for the number of protons, which is nothing but the atomic number. And in a neutral atom, the atomic number is the number of protons or the number of electrons, because number of protons and the number of electrons are same in a neutral atom. Now what are we talking about? To get minimum energy state. Guys, do you remember the relationship between the stability and the energy I always tell you in the class? It's actually stability is inversely proportional to energy. So if for anything to be much more stable, the energy possessed should be minimum, should be lower. Do remember this. Okay? And what is exactly happening over here? If you would see in the outermost shell, we have 1, 2, 3, 4, 5, 6, 7, right? And when we get extra electron, then ultimately the electronic configuration becomes stable. What exactly becomes stable? The electronic configuration becomes stable. And they're all doing to achieve octet electronic configuration, which is NS2, NP6. That's it. Do we have exception? Yes. Don't worry. It's not an exception. It's simply because of that the first shell cannot have P subshell. That is the only reason behind it. And what is the so-called exception that you say? It's actually 1s2 as well, which hydrogen and helium has to achieve. Helium has the 1s2 electronic configuration. Hydrogen in many scenarios wants to achieve this, the 1s2 electronic configuration. So do remember that. Lower energy, more stability, amazing. And now let's talk about different types of chemical bonds and we will define them one by one. But I have actually given you the glimpse of ionic bond. It's an exchange, total exchange. One clearly doesn't want it, another clearly wants it. They will be like, I don't want it, you take it. Don't worry, I don't want it back. That's what happened with sodium and chlorine. Sodium didn't want that electron back, but it gave it to the chlorine totally. Now, this is what it is. So the ionic bond, example, NaCl plus minus, okay? When we talk about covalent bond, it's all about sharing. We'll talk about this, okay? we'll talk about sharing. And now over here, whenever we're talking about sharing, we have an example, something like hydrogen and hydrogen. Okay? We're talking about coordinate bond. What exactly happens in coordinate bond? The donation of the lone pair. We'll talk about this as well. Okay? We'll dive into that. And then we have the fourth one, the metallic bond. Iron and iron molecule, atoms, between those atoms, there is a metallic bond. We'll talk about that as well. These four are strong ones. These four are the strong ones. Whenever we talk about the weak bonds, we have hydrogen bond and we have van der Waals interactions. Even we will discuss about this, okay? And now let's talk about the ionic bond for once, and then we will get into the covalent bonds, okay? So should we memorize electronic configuration? No. One should never memorize the electronic configuration. One should always memorize the atomic numbers. One should always memorize the atomic numbers, and you should know the trend related with this Aufbau's principle. What is the trend to fill the electrons? It is 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, and so on. And how is that? How do we know this? All because of n plus L rule. Lower the n plus L rule value, the electron will go over there. So why 4s comes first? Because the n plus L value comes out to be 4 plus 0. But here it comes out to be 3 plus 2. So it is 4, this is 5. So electrons will get into 4 first. 4s first. Okay. Now let's move ahead. Over here, what are we really talking about? This has to be atom 1, which is actually having, let's say, 1 or 2 electrons in their outermost shell. And there will be an atom 2, which is going to be a non-metal always, most probably. And then there is going to be an electron transfer. Whenever we are going to talk about sodium losing 1 electron, it's +1. When chlorine gaining 1 electron, it's -1. How to write the formula? This number, it's a 9th class technique. Put it over here. Put it over here. Na1Cl1 can be written as NaCl. What about magnesium chloride? So magnesium, if we talk about magnesium, boys and girls, the atomic number comes out to be 12, which clearly means the electronic configuration comes out to be 1s2, 2s2, 2p6, 3s2. That's how it is. How many valence electrons? 2. If I remove these 2 electrons and if I make it 3s0, this becomes +2, right? So what is going to be the formula with chlorine? These 2 electrons have been given to chlorine each chlorine. Magnesium +2 gave electrons to chlorine. Each chlorine having 1 extra electron. What is going to be the formula? MgCl2. So you can actually always use this. Any doubts? Yes, the cross method, right? So don't worry about that. And now let's move ahead, and this is what we're talking about. When we are having magnesium having 2 valence electrons, but chlorine, 1 chlorine can accept 1. Why chlorine should have 2? Let's say you go to MACD. How many of you go to MACD? You went to MACD. You want burger. The person at the counter says they have 5 burgers. They have 5 burgers. But you only want 1. You only want 1 burger. Just because they want to sell 5 burgers, will you have 5 burgers? Yes or no? I won't have it. If I just want 1, I'll just have 1. Right? So ultimately they have to find 4 more people looking for 1 burger each. Right? Correct? So that's what is going to happen over here as well. Magnesium wants to give 2 electrons, exchange entirely. But 1 chlorine can have just 1, because chlorine cannot go against its electronic configuration. Another chlorine is also going to come, and then they will simply take 1 electron each, and magnesium is also satisfied. Only Baba Gatava. Good one. Valence bond form when there is a transfer of electron, and covalent bonds form when there is sharing of electrons takes place. Amazing, Lakshika, amazing. Lakshika OP in the chat, boys and girls. Lakshika OP. And now, I really like the students who actually are active with me and they write whatever they are understanding. It's amazing. And now, okay, now pay attention. The type of bond in which mutual sharing of electrons takes place is called covalent bonding. What is mutual sharing? It clearly means, you know what is mutual sharing? Let's say this is you. See how great I am with human figures. And let's say this is your friend. Okay? And you guys actually decide that today we will have one ice cream. You guys actually go for an ice cream and you do not have more money. You just have money only for the one ice cream. Half ice cream, this ice cream will stay at the middle. Some amount is going to be taken up by one, some amount is going to be taken up by another. That's the mutual sharing. Similarly, in the case of atoms as well. Hydrogen having one electron, okay? Another hydrogen having one electron. Okay? Now guys, let me know. How many electrons does one hydrogen need to become stable? Because the electronic configuration of hydrogen comes out to be 1s1. For how many electrons this hydrogen is hungry? One electron only. Hydrogen needs one extra electron to make it 1s2 or like a helium noble gas configuration. Correct? But just think about it. When this hydrogen needs one electron, can this hydrogen entirely take this and keep this hydrogen like H plus and H minus? Which hydrogen is more powerful? You guys have to let me know. Hydrogen A or hydrogen B? Which hydrogen is more powerful? If you have an answer A or B, you're stupid. Because this is hydrogen, this is hydrogen. It's the same question if I ask, there are two Vidyas. You have your mirror image. You know, you have somebody exactly like you, you're a clone. Who's going to be more stronger? It's going to be same, right? That's the same with the hydrogens as well. Okay? Don't give me an option A or B, please. Okay? One hydrogen and the second hydrogen both are identical when it comes to snatching away the electron as well. Do remember one thing. If this is hydrogen and this is hydrogen and both of them are having electrons, which hydrogen is more electronegative? I would like to put, in this way. You should remember hydrogens, the atoms are of hydrogen, hence the electronegativity is not going to change. And when the delta En, the difference between the electronegativity is lesser or equals to 1.7, you always have a covalent bond. You always have a covalent bond. Whenever you have delta En value greater than 1.7, then you will always have an ionic bond. I'll give you an example. Are you ready? But for that you have to tell me the electronegativity of chlorine and the electronegativity of sodium. We'll do that. Guys, do you remember the electronegativity of fluorine? It's 4. What's with the chlorine? It's somewhere around 3.2, 3.3. We'll keep 3.2 for now. What about lithium? It's 1. What about sodium? It's 0.9. Check the delta En value. Delta En between sodium and chlorine, 3.2 minus 0.9. Even let's say this is 1. The answer over here is which is going to be somewhere around 2.3. Correct? Is 2.3 greater than 1.7? It's ionic. Okay. Now let's talk about more. What is the delta En value over here? Delta En value is 0. Both hydrogens are having same electronegative values. Yes or no? Electronegativity means, sir, today I am not going to teach you electronegativity. In the previous class I taught electronegativity when we were about to finish the periodic table chapter. So do watch that recording. So do remember that. So whenever we have En value less than or equals to 1.7, do you want to have an example? Let's talk about carbon and oxygen. So carbon has an electronegativity of 2.5 and oxygen has an electronegativity of 3.5. If somebody is thinking that how to remember these values, then you just have to come on a daily basis on this channel. I give each and every trick. If you think that just coming to one particular channel for once will actually solve all your problems, then you are at the you're actually thinking wrong. So do subscribe to the channel, boys and girls. And over here, what is going to be the delta En value? Delta En is equals to 3.5 minus 2.5, which is 1. 1 is lesser than 1.7. CO2. In CO2, oxygen and carbon, they both are having covalent bonding. So this is how you should always remember, okay? And now, what is exactly happening? Over here, this hydrogen wants 2 electrons. See, it actually took 2 electrons. This hydrogen wants 2 electrons. Are they sharing these 2 electrons now? Yes or no, guys? Do you see this sharing? This is what is happening over here, the mutual sharing. And for one covalent bond to happen, to be present, there should be 2 electrons. The sharing should happen from both the ends. The sharing should happen from both the ends. That's the covalent bond. Now, what are we really looking at? What type of atom 1 and atom 2 are? See, the number of electrons comes out to be 1, 3, 5, 7. Which type of elements have valence electron 7? Fluorine, chlorine, bromine, iodine, halogens, right? So this A is a halogen, this B also is an halogen, but let's keep it like both of them are not same. What is exactly going to happen? How many electrons does A require? Just 1 extra. How many B requires the electrons? 1 extra. What's going to happen? A says, I'll silently take this electron. B says, even I'll silently take the electron. But they do not know that ultimately they both are sharing each other's electron. How many electrons are getting shared? Total 2, 1 from each. This you can actually keep it, whenever we make like chlorine dash chlorine, that means 2 electrons. Always remember. 1 dash, 1 bond means 2 electrons. They are actually having a single bond between each other. What are they having? The single bond between each other. Or you can actually show it like this. They both are sharing. This is the covalent bond. Clear? Is this really clear to each and everybody? Because ultimately, whenever you're going to look for, see, the electronic configuration of this one. This is going to be NS2 NP6 right now. 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. For this one, 1, 2, 3, 4, 5, 6, 7, 8. With the sharing, if they can actually achieve the noble gas configuration, noble gas like configuration, then ultimately, yes, covalent bond is going to be there. Guys, if you're liking the video, if you're liking my efforts, do hit the like button, okay? And share it amongst your friends. And over here, guys, pay attention. Now, what are we really looking at? The examples. Chlorine, iodine, HCl, HBr, H2, F2. Guys, let me know the delta En values. Okay, we are going to write delta En values. Whenever the delta En, whenever the elements are same, it's 0, it's 0, it's 0, and it's 0. What is the electronegativity of hydrogen? Somewhere around 2.1, 2.2. Okay. When we talk about chlorine, it's somewhere around 3.2. When we talk about bromine, it's somewhere around 3. That's what you have to remember. Okay. For iodine it is 2.8, 2.7. Okay. Now look for that. What is the difference between both of them? You would see 1.1. Is it a covalent bond? Yes. 3 and 2.1. A difference of 0.9. It's a covalent one. Now I'll ask you something. A very good question. What about HF? Hydrogen and fluorine. Is it a covalent bond or an ionic bond? But you do have to first of all calculate. You do first of all have to calculate the EN, the delta EN value. Do not tell me the answer without calculating EN, because whosoever is going to give me an answer without an EN, delta EN, I will not consider your answer. How did you find EN? I have given you the trick in the previous class. So I'll give you the trick once and for all today as well. Write the second period. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Start with fluorine. It's the most electronegative element with a 4 value. Then 3.5. Decrease 0.5, 0.5. Then 2.5. Then ultimately boron with 2.0. Then ultimately 1.5. And then 1.0. Hydrogen comes out to be around 2.1. Sodium comes out to be around 0.9. Potassium, rubidium, cesium. Potassium and rubidium around 0.8, 0.8 and then 0.7. Okay. For the chlorine 3.2. For the bromine 3.0, which is same near to nitrogen, and iodine 2.7. You have to remember at least few. Come on. You are a JEE student, right? Everybody should know a bit more. Yes. So EN approximately 2. Amazing, Lakshika. You're absolutely correct. But you are wrong as well. But I won't put it on you. According to what I have told you, you're correct. And now I'll tell you where we are going wrong. Fluorine has the electronegativity 4. Hydrogen has an electronegativity 2.1. Now guys, pay attention. Whenever we go for delta EN, fluorine has 4, hydrogen has 2.1. Correct? The delta EN value comes out to be 1.9. In actuality, you should remember this number is actually greater than 1.7. So if number is greater than 1.7, it should be ionic, but HF is going to be hydrogen and fluorine has a covalent bond. Lakshika, you're absolutely right. It's not going to be ionic, it's going to be covalent. But if you get any other two elements, find the delta EN value which is going to be greater than 1.7, then these two elements are going to have an ionic bond. But over here, hydrogen and fluorine are the ones which are actually having covalent bond. Do remember this. Did you like this? Guys, and everybody has to remember all of these electronegative values. Do you want more? I can give you more. So magnesium, similar to lithium. Aluminium, similar to beryllium. The diagonal relationship 1.5. Okay. So do remember these. Okay. And when we talk about, I think this is fine. This much is fine for you guys. Correct. Okay? Or do you want more? Shall we go for more? You should remember these values. There's no other way. Okay? Now, let's talk about the covalent bonds. Over here, we are looking at O2, we are looking at CO2, we are looking at C2H4. Why is that? We're talking about double bonds. What exactly happens? Oxygen. How many electrons does oxygen has? The valence ones. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How many electrons does oxygen require to make its electronic configuration as NS2, NP6? 2 extra electrons. How many electrons does this oxygen requires? How many electrons do you see getting shared? 4 electrons. when 2 electrons make one bond, 4 electrons will make 2 bonds. This is the only reason oxygen has double bond with the oxygen. We'll do it again. Okay? The carbon dioxide. How many valence electrons does carbon has? 2p2, 2s2, 2p2. Correct? Total 4. Let's do it with the oxygen. How many does carbon require to make its octet complete? 4 more. So pay attention, boys and girls. So the carbon. Is now carbon having 8 electrons? Yes. What about oxygen? Do you see 8 electrons right now? The octet of carbon and octets of oxygen, all of them are complete. Correct? And that's where, what's the number of bonds between oxygen and carbon? 2. Double bond, double bond. Is this clear? We'll do it with another, the last one as well. Okay? Do make this in your notebook. Carbon, carbon. How many electrons? Total 4, right? 1, 2, 3, 4. 1, 2, 3, 4. How many hydrogens? 4. How many electrons does one hydrogen has? One each, correct? Now, but how many electrons does hydrogen wants? It wants 2 electrons only in total. See, hydrogen's duplet is complete. Duplet is complete. Duplet is complete. Duplet is complete. But what about carbon? Carbon requires 8 electrons. Pay attention. 1, 2, 3, 4, 5, 6, 7, 8. This carbon is satisfied. What about this carbon? 1, 2, 3, 4, 5, 6, 7, 8. Is this clear? Now, do you see a double bond? Do you see single bonds? Single bond, single bond, single bond, single bond. Carbon, hydrogen, single bond, carbon, carbon, double bond. Clear? And now let's talk about some triple bonds as well. Guys, pay attention. Nitrogen. How many electrons does nitrogen has in its valence shell? It's 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How many electrons does nitrogen require to complete its octet? 5 plus 3, 10, 8. 5 plus 3, 8. 10. Acha, now, guys, pay attention. Do you see 8? 1, 2, 3, 4, 5, 6, 7, 8. Correct? And now, guys, pay attention. How many bonds do you see? How many bonds do you see? It's actually triple bond. Correct? Let me know. Yes or no? Getting it? Simple. It's triple bond. So nitrogen have triple bond between whenever we talk about N2 gas. Cool? And now we will talk about the Lewis representation. Whatever I have been doing is actually giving you some glimpse of Lewis representation only. Okay, we'll talk about more. So what are we really looking at? Hydrogen, H2. We're looking at Lewis representation. What we do is, whenever we see 2 electrons getting shared, we make it 1 dash. The shared electrons should be represented as 1 dash. The rest unpaired lone pairs, which are known as lone pairs. Lone means alone. The ones which didn't get shared, alone ones, are going to be shown as double dots. Okay? Do remember this. Now, let's do this. So, what if we have O3? So, we'll make the structure of O3, guys. Don't look at there. Don't look at that place. oxygen, oxygen, oxygen. ठीक है? How many electrons? 6. See, do you know that oxygen has double bond with oxygen? See, this is an oxygen molecule, but there is one more oxygen which comes up. He's crying, he's sad. This oxygen says, I have 6 electrons, I need 2 more. Hey oxygen, hello, can you give me more? He says, no, I don't want to, because ultimately I have 1, 2, 3, 4, 5, 6, 7, 8. My octet is complete. If you will share 2 more electrons, then my number of electrons will become 10. I don't want to disturb my electronic configuration. You go away, please. I'm so sorry. Okay? But ultimately, this oxygen was going away. But then this oxygen says, wait. I can do something for you. But I don't want anything in return the way I do to you guys. And I always keep you in the chat, but I don't want anything in return from you guys. So, but yeah, pay attention. This oxygen says, these 2 electrons, keep it with you. But you have to be close to me. You cannot just take it and go away. Those are my electrons. You can't just take it and go away. Those are my electrons, but you have to stay together, close, so that these electrons are close to me. But I don't want anything from you. So how many electrons does this oxygen, third oxygen has? 1, 2, 3, 4, 5, 6, 7, 8. This bond is known as the coordinate bond. The coordinate bond, or also known as dative bond. I'll write it for you. Coordinate bond or dative bond. Always remember, a coordinate bond is also a covalent bond, but it's a sharing only. But this oxygen, this atom says, I will share electrons, but I do not need anything in return. It's just like me and you going out to eat ice cream, and I am the only one who just pays for it. And I don't want you to pay it, but we both share the ice cream. That's how it is, okay? So this is what is exactly happening. This is the coordinate bond, is what you have to remember. Clear? Let me know. Give me a smiley in the chat and let's move ahead. And now, what are you really looking at? So, this is one bond, this is one bond, 2 bonds, this is one bond, single bond. Pay attention. Do you see double bonds over here? Do you see a single bond over here? Yes. What's with a positive and a negative? We'll talk about that. Who's losing from when we are talking about oxygen 1, 2 and 3? Which one is losing electron and which one is gaining electron with, who actually paid for the ice cream and who actually had ice cream for free? This is what I'm talking about. So who had the ice cream for free? The third one, right? And who paid for the ice cream? The one. So whose expenditure is this? It's for the first oxygen, right? Just put a plus sign. And who had it for free? This one, the negative sign. Okay? And then do not show the arrow. If you make a plus and a minus sign, simply make a line. Okay? And in this scenario, remove electron. Why is that? Because you should always remember, line represents electron. Whose electrons are these? Belongs to first oxygen. Clear? Yes or no? First losing and third one is gaining. Amazing, Lakshika. Third 8 for free. Amazing, Vidya. Correct? So this is what you have to remember. Now pay attention. There's no arrow. It's a single dash. Positive sign on the one which actually gave its 2 electrons, the lone pair, and the negative sign on the one which actually gained these 2 electrons, or the lone pair. Okay? Do remember this. So this is how you actually can write the Lewis representation for molecules. Can you do it for more? I am going to ask you something. Now, pay attention. I'm doing it for you. You guys have to let me know on what particular element atom, I should make a positive and the negative sign. I have nitrogen, I have hydrogen, hydrogen and hydrogen. I made ammonia. How many electrons does nitrogen has? It's of its own 1, 2, 3, 4, 5. Okay, 6, 7, 8. These are from the hydrogens. Is the octet of nitrogen complete? Yes. There's one more hydrogen which comes up. How many electrons is this hydrogen having? 0. It's a plus. 1s0. 1 electron of hydrogen has taken up by somebody. This hydrogen is crying for how many electrons? 2 electrons. Why is that? Duplet rule, to make its electronic configuration as 1s2. Now what's going to happen? Over here, this hydrogen comes with the nitrogen. I do not have anything to share. Can you give me your electrons? Nitrogen says, yes, I can, but you have to be close to me. Hydrogen plus says, no issues. So these 2 electrons are given to hydrogen. Now, who is going to have a positive sign? Is this positive sign going to stay here, or is this positive sign going to be here? Let me know. What do you think, boys and girls? Let me know, boys and girls. Come on, come on, come on. As quick as possible. Lakshika is saying NH3 Lewis base electron de dega. Amazing. Amazing. N would be positive. Now I'll make the Lewis dots, this Lewis representation. Nitrogen. I'm not making the shared electrons because these are dashes, okay? This one gave electrons to hydrogen. This is how it is going to be. Okay? Yes or no? But there should be one negative sign as well. Hydrogen had a positive sign. If you are going to make a negative sign as well, both of them are going to get nullified. So you do not have to put a sign here. Amazing, right? So this is how you can actually practice n number of times for any particular molecule. And now let's move ahead. Over here we are talking about write the Lewis dot structure for carbon monoxide molecules. We'll do it, okay? How many bonds are going to be there between carbon and the oxygen? You guys have to let me know. Over here we have carbon 1, 2, 3 and 4. Oxygen 1, 2, 3 and 4 and 5 and 6. You know what exactly happens? Carbon says thank you. Oxygen says thank you. But carbon says I'm not happy. And why is that? Because carbon is still having 6 electrons, not 8. Carbon says, oxygen, can you do something? Please try something else, no? Oxygen says, no, I do not need any electrons from you. My octet is complete. Okay, but I can do one thing for you. Why don't you take my 2 electrons, but I do not want anything in return? These are the 2 bonds. These 2 electrons will be given to carbon. But I made these 2 electrons in the circle of oxygen, the circle which belongs to oxygen. So this is close to oxygen, but it is also with the carbon. So how is it going to be? Something like this. This is the 3rd bond. Which one should have a positive sign and a negative sign? Is it good? Sir, why is octet 8? Vidya, the reason it is all because of the electronic configuration, which should be NS2 NP6. The noble gas like configuration NH2 NP6. How many electrons? 2 plus 6, which is 8. Ice cream for your hard work. Melt ho jayegi. Thank you. You can have the ice cream as well. Acha, is this really clear to everybody? Do remember this, okay? If you do not want the signs, plus and minus, simply it's going to be like an arrow, oxygen's lone pair, carbons lone pair. Do remember this, okay? And now let's talk about the Lewis structure for nitrite ion. NO2 minus. Always remember, try to make the less electronegative element in the middle. The less electronegative element in the middle. Nitrogen is less electronegative than oxygen by 0.5 value. How many electrons? 1, 2, 3, 4, 5. Pay attention. How many oxygens? 2 oxygens. Good. One more oxygen is there. What did I do? I made 7 electrons for oxygen. Is this okay to make 7 electrons for oxygen? Here it's okay. Why is that? I'll tell you. This is one lone pair. This is another lone pair. This is the electron of oxygen. This is the minus sign. This one is the minus sign, boys and girls. Okay, this is the extra electron. Okay. So how many electrons does oxygen has right now? 1, 2, 3, 4, 5, 6, 7, 8. Octet complete. 1, 2, 3, 4, 5, 6, 7, 8. Octet complete. And when we talk about nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. Octet complete. Now let's remove the unnecessary things. I mean, I'm just removing up this, कहाँ गया? This is the Lewis dot structure for nitrite ion. When will you start mole concept? When you will excel in chemical bonding. We'll start mole concept after chemical bonding. Yes, we'll start after chemical bonding. And chemical bonding I am going to end within 3 and maximum 4 classes. So by this week, I mean, yeah, next week we are going to start mole concept. Okay, amazing. Is this clear? Now guys, pay attention. What are we really talking about? We are talking about bond length. How do we know whether the bond length is more or the bond is less? So, the length of the bond. Is it small? Is it long? How do we get to know? Whenever we have 2 atoms which are interacting, but we also know where their nucleus is present. This is the nucleus of the first atom. This is the nucleus of the second atom. The distance between the nuclei, this distance is bond length from here till here. That's it. In words, distance between 2 nuclei of the adjacent atoms is the bond order. Oh, bond length. Do remember that. Good. Size se, yes. And how do we used to calculate the size of an atom? When we have 2 atoms forming up a bond, covalent, metallic or van der Waal having interactions, you just divide it by 2. From here till here it's the atomic radius, the bond length. Okay, is this clear? But when 2 atoms are different, then do not try to calculate the bond, the atomic radius, but you can still calculate the bond length. For calculating the atomic radius, you need both the atoms similar. Both the atoms should be same. Okay, and now let's talk about the bond angle. For the bond angle, there should be requirement 3 atoms required. Because don't ask me later, sir, what is the bond angle between hydrogen? You cannot talk about the bond angle, okay? For an angle to be present, there has to be 3 points. Point A, point B, point C. Then you talk about the bond angle, right? Similarly, you need 3 atoms. 1, 2, 3. And this is how you have to remember. But there are 3 very important bond angles that you have to remember. Pay attention. The one is oxygen, hydrogen, oxygen, hydrogen. Okay, what is the bond angle over here? This comes out to be 104.5 degrees. The exact is 104.45. You can remember the approximate 104.5. Now add 1.5 to it. I'm talking about nitrogen, hydrogen, nitrogen, hydrogen. Any of these bond angles. This one is 107 degrees. If you just add 1.5, 2.5, yes, 2.5. Yeah, 2.5, okay? And add again 2.5 to this. The angle that you guys are going to get is going to be approximate 109.5 degrees. Is this clear? We will, whenever we are going to get into sp2, sp3, we'll talk about that later. But yeah, see, anyhow, all these particular molecules are having same hybridization. So let's not talk about hybridization today, Lakshika. It's good that you know it. But right now over here, if you would see, all these molecules are having same hybridization. For those who do not know hybridization, don't worry about this word. We'll do it in the next class. Do remember this, okay? So this is how it's easier for us to remember an approximate values. 104.5, add plus 2.5 degrees, and then add again 2.5 degrees. You will have good precise answers, okay? And now let's talk about bond enthalpy, or in other words, bond energy. That means how much energy is there between one atom and the second atom. How strongly they are actually holding each other. If they are holding each other very strongly, then you will require too much energy to break it. If they're even if they are holding up with 3 bonds, nitrogen, nitrogen, triple bonds, and or if we talk about oxygen, oxygen, or if we talk about hydrogen, hydrogen. So if the number of bonds are going to be more, the bond enthalpy is going to be more. Bond enthalpy or bond energy is like how much energy do you need to actually break the bond, okay? So there is a molecule of an atom A and of an atom B. How much energy do you have to put over here to break it? So that is the bond energy. That is, in simple words, nothing more is available over here. That's it. Okay? The values that you have to remember over here is, the values are going to be always in kilojoules per mole, kilocalories per mole, or kilojoules per mole, which will be given to you in the question paper. Okay, they will be giving you such values only. So what is it? It is defined as the amount of energy required to break 1 mole of bonds is what you have to remember. Bond enthalpy, bond energy, or bond dissociation energy. What is dissociation? To keep them away, to dissociate them, to keep them apart. Association means bringing things together. Dissociation means keeping it apart. Okay, so do remember this. It's easy. Energy to break the bond. That's it. That's bond energy. And now let's talk about the bond order. Bond order means how many number of bonds are available between one atom and the another one. So when we talk about single bond, single bond means bond order value 1. Example, hydrogen, hydrogen, fluorine, fluorine, chlorine, chlorine, so on. When we talk about double bonds, bond order value comes out to be 2. Is this tough to remember? Don't say that. Over here, We have an example, oxygen double bond oxygen, right? So we have carbon double bond carbon, right? Now let's talk about the bond order, which is 3. How many bonds are we going to talk about? Single bond, double or triple? Easy, right? Bond order 3 means triple bond has to be there. So there is a molecule which is showing all the types of bonds. Okay? Here the bond order is 1. Here the bond order is 3. Here the bond order is 1, twice, 1, 1, 1. When you see one complete bond and one dashed line, this means half bond. Okay? 1 plus half, which comes out to be 1.5. The bond order comes out to be 1.5 is what you have to remember. Yes, the bond orders can be in fraction, decimals as well. 1.5, 2.5, such things exist. Okay, so do remember that. Easy peasy lemon squeezy. Amazing. Now let's talk about the resonating structures. When in simple words again, when we talk about the resonating structures, it clearly means when the molecule is already available, when the molecule has formed, is there a possibility of exchanging electrons within the molecule? Can some electrons go from one atom to another? That's what we're talking about. Okay. So guys, now pay attention. Guys, which is the dative bond? This is the dative bond, A or B? First of all, do let me know. Which is the dative bond? Coordinate bond. It's actually going to be B, right? See this. 1, 2, 3, 4, 5, 6, 7, 8. This is satisfied. 1, 2, 3, 4, 5, 6, 7 and 8. Even this is satisfied. Correct? 1, 2, 3, 4, 5, 6, 7, 8. This is the dative bond, the B part. Okay, so do remember that. Let me just remove hydrogen. There is no point of having hydrogen in the case of ozone. Over here we are talking about O3. Okay, now guys, pay attention. What exactly happens with the ozone, or there are a lot of different molecules which can actually show resonance. We're taking an example of ozone. For this oxygen, with this oxygen and this oxygen, they're forming up double bonds. But with this one, they are forming coordinate bond. Do you really think that something is special with this oxygen and this oxygen is different? The answer is no. Both of these oxygen atoms in real life are same. In actuality, they are same. So simply there's no point of giving all the double bonds here and only the coordinate bond over here. What will this oxygen do is, it will be like, I'll treat both of these oxygens same, in the same way. What exactly happens, guys? Now pay attention. Okay? This is oxygen 1, this is oxygen 2, this is oxygen 3. Now just see, 3 is having a double bond, this is 1 and this is 2. Now between 1 and 2 there is a dative bond, between 1 and 3 there is a double bond. Now what is exactly happening in actuality? Now see, one oxygen having single bond with one oxygen with single. See, in both of these structures, if you would see, single bond and this single bond is same, correct? Even this has a single bond. There is just one bond which is making a difference. There is just one bond making a difference. Sometimes this double, this second bond is with the one oxygen. Sometimes it's with the another oxygen. Correct? Now pay attention. Instead of making it one extra bond on any of the sides, what did I do? I shared the second bond between both of them. I shared second bond between both of them. So what is the bond order whenever we talk about oxygen, this ozone? What is the bond order between oxygen and oxygen in ozone? It's not 1. It's neither 1, it's neither 2. It's 1.5 and 1.5 is what you do have to remember. This particular last diagram is known as resonance hybrid. Do remember this. This is known as resonance hybrid. Is this clear? Let me know. So does dative bond always make a single bond? Yes. Because a dative bond is always a donation of 2 electrons, and 2 electrons can always form, shows single line. Single bond it is always going to be. Okay? And now let's talk about, explain the structure of carbonate ion. How are we going to write this? CO3 2 minus. 2 minus is the charge. How many carbon? 1 carbon. How many electrons this carbon has? 4. See, 1 2 3 4 5 6 7 8. Oxygen satisfied. Okay? What about this carbon? 1 2 3 4 5 6 7 8. Even this carbon is satisfied. What about these oxygens? 1 2 3 4 5 6 7, and the 8th one is the negative sign. This extra electron is from somebody who left. Hydrogen left with its own electron. Okay? Similarly, 1 2 3 4 5 6 7 and 8th, the snatched one. The electron which has been snatched away from somebody else. Now, guys, pay attention. This is single bond, this is single bond, and this is double bond, and this is double bond. I'm going to ask you something. What's the difference between this oxygen and this oxygen according to carbon? No, oxygen is oxygen, right? So this happens. Oxygen with a negative sign, double bond O, oxygen with a negative sign. Now pay attention. Carbon double bond O, no, give me a second. So any of these oxygen can actually have double bond. Who are we to decide? Because all the 3 oxygens are same. Who are we to decide which all 2 oxygens should have a negative sign? No, correct? So this is what you should remember. Carbon make oxygens, all 3 oxygens now. Anyhow, in all the 3 cases, single bond is consistent. Now make it like this. Okay, this is how you should make. What will you write about the bond order? How will you write about the bond order? How many oxygens are there? 1, 2 and 3. But how many bonds are there? 4. Number of bonds are more, number of elements are less, है ना? Which are getting these bonds. So number of bonds 4 divided by 3. This is the bond order. 4 by 3 is the bond order between carbon and oxygen. Carbon and oxygen. Okay, so do remember this. And when we talk about the charge, how much is the charge? The total charge that we see is -2. But divided by how many atoms? 3. So do write this. -2 by 3 charge on each oxygen, right? 1.33 is the correct bond order and 4 by 3 is correct. Yes, -2 by 3. Yes, thank you so much, Vidya. Is this clear? Now we are going to dive into questions, and this is where let's dive. And by the way, remember, boys and girls, I am going to finish your chemical bonding, whatever time I have given it to you. We'll start mole concept, in the next week. Pay attention. the isoelectronic set of ions is, isoelectronic means same electrons. For that you should know the atomic number first. So if you talk about atomic number, we have fluorine, lithium, sodium and magnesium. Fluorine, lithium, sodium, magnesium. Do we have anything else? We have nitrogen as well, we have oxygen as well. 9, 3, 11, 12, 8, 7. Lithium can never have same number of electrons compared to any one of them. It can either gain 3, 2, 1, any element which can to an extent gain electrons by its own could be 2, 3, 1, something like that. From 3, it is going to have 3 electrons, it can never compete with others. Now pay attention. Over here, let's remove the lithium from the race. So we will never talk about the first option and the second option and the third option. You have the answer. Acha, anyhow, let's go with the actual solution. Now, what are we talking about in the last question? N3 minus 7 protons, 3 electrons extra, 10 electrons. Oxygen 2 minus 8 protons plus 10 electrons. Fluorine minus 9 protons plus 10 electrons. Sodium plus 11 protons plus 9 electrons. Plus, done, right? What if magnesium has to become isoelectronic to them? Plus 2. 12 protons plus 10, 12 protons plus 10 electrons. I did something wrong. Give me a second. This has to be 10 electrons, yaar. Hai na? Good. So then what is left? Lithium is left. Okay. Yes. And by the way, magnesium 2 plus is also the correct one, only because of lithium plus it went wrong. If instead of lithium plus there would be fluorine minus, your answer would be correct. Okay. And yes, now moving on to the next one. Which of the following compounds contain no covalent bonds? No covalent bonds. Think about it. Phosphorus, hydrogen. Boron, hydrogen. Potassium, calcium. In order to have no covalent bonds, we're talking about ionic bonds, correct? And I have told you, whenever we are going to have an element which is highly electropositive and one which is highly electronegative, then only you will see the ionic bonds. Potassium lies to group 1 elements, chlorine lies to halogens, group 17. The correct answer to this question is absolutely C. Amazing. And now let's move towards the next one. Which of the following is covalent? H2, calcium oxide, KCl, sodium sulfide. The delta En value should be as low as possible. The correct answer to this question is absolutely going to be A, which is hydrogen and hydrogen. Let's talk about the next one. The total number of electrons that takes part in forming the bonds in N2. Let's see. The total number of electrons that takes part in forming up the bonds in N2. How many number of electrons do you see? How many bonds? If the answer comes out to be 3 in your mind, each bond having 2 electrons, 3 bonds having 6 electrons, right? I'm taking up a class, man. What's your problem? Ganda bacha. He's sleeping right now over here. No, it's actually somewhere around 10:20. So this is your sleeping time. You sleep. Chalo. Now the compound which contains both ionic and the covalent bond. Ionic as well as the covalent bond. So ultimately there might be a possibility that we are actually looking for there should be more than 2 elements or more than 2 atoms. Acha. Carbon hydrogen bonds, all of them are covalent. H2H2 only covalent. KCN, KCl. Potassium and chlorine only ionic. But in the case of potassium and CN, so over here what are we having? We are having the ionic bond and we are having the covalent bonds as well. Pitai. Okay, boys and girls, let me know. He actually talks too much. Yes, he actually talks, he answers everything. Who's ganda bacha? Chalo. Are you guys able to hear him? Is it? Yes or no? No pitai. No. I'm not doing any pitai to him. I'm giving, something like bum slaps to him. He likes it. Acha, anyhow. So now we're talking about KCN, that is going to be the correct answer. And now we are absolutely at the end of this class. If you have any doubts, you can ask me on Telegram or you can actually message me on Unacademy app. And apart from this, you can actually message our doubt experts on our Unacademy app. So you can ask unlimited doubts, any doubt at any point of time. But the only thing that you should make sure is that the image should be clear. No multiple doubts in one image. All the options should be clear. No handwritten material. Just let us know from which particular topic, which particular subject you're talking about, and we will get back to you with the high quality video solutions in English as well as in Hindi. And it can also help you in homework as well, right? So do not forget to use this feature whenever you have a doubt. Okay? Yes, it's a kind of shabashi. It was a wonderful session. Amazing. You are the only ones who make my session wonderful. So do not forget to come live daily. We are going to crack it, right? And you do not have to worry about anything then. All the best. Take care. Stay safe. Subscribe to the channel. Like this video. Share among your friends. And let's meet tomorrow. All the best. Take care. Stay safe. Bye-bye, everybody.